Hi people. So have you ever wondered how some websites load very fast and others take too much time to load basic data, even if you have the best internet available with you? So the reason behind all this is caching. So yeah, your compute powers do matter, but to make it blazing fast, they will be implementing some kind of caching. So today we'll be covering a topic called caching. In this video, we'll cover what is caching, why we need caching, what are the different pros and cons of using cache, what are the different strategies that we can use to implement cache, tools can we use to implement cache in our application. So in case you need any drill down information on any of the topics, I can cover either of them in the next separate videos. Drop me a comment to tell me what areas you want me to cover next. Now let's understand what is caching. So caching is a concept that means we are keeping the copies of frequently accessed data in a very fast storage layer that helps us to procure the future requests for the same data. Now let's talk about why we need cache. Imagine you are building an Amazon level of a product and you got a new fancy product that is going on a sale very quickly and you are expecting a very high traffic for that same product. Now the detail of that entire product will be same irrespective which user is loading that, right? So anything that could change is its pricing, but they will not frequently change. So how to serve the entire page with that product? Obviously I have the rest of the products to be displayed as well. So this page is again in a very high demand, so I will need to find a different way to provide the information so that this page can be served to multiple users at the same time. Since the information is not changing, so I can leverage caching, which would help me in numerous number of ways. One would be to lower the latency. The load time of your page will reduce when you will implement a caching layer, because you will not hit the database to serve that entire page. You will have it already stored in your in-memory data caching layer. Your images will be cached, so you can immediately push out the data whenever it is asked. So second thing is the scale. So when we talked about the number of users here, so obviously for a new product that is going live and getting on a sale, so we need a scalable solution that we can provide the same product page to millions of users at the same time. Then if just in case the amount of users accessing the portal is too high and my server or my database cannot handle that traffic, so there's a high chance that my application goes out of availability. Now let's talk about the pros and cons of implementing caching in our application. So let's start with the pros first. The first is the performance of our application. With caching, we have a better performance. We'll have a scalable application that would allow us to serve huge active users at the same time. Application, since we'll reduce the database calls, so our application would be cost efficient and available at the same time, making the application more user friendly. Now let's cover the cons of implementing the cache. Since we are storing the data in memory, so there is a chance where the data could go stale. That means in case of Amazon, the pricing got updated or the number of products got reduced or changed or anything else changed. So there's a possibility that I would serve old data to my users. Then there is a memory overhead where I need to use additional RAM that would allow my caching layer to work better. And on top of it, so when we are implementing cache, to avoid having stale data, I'll need to invalidate my cache. So invalidation of cache is like to remove or update the data that you have in your cache layer so that you serve the best updated data possible from your cache layer. Now let's talk about different strategies that we can use to implement caching. So the first strategy that I would cover in this is cache aside, which means we'll have the cache as the first reference of data for every read request that we have. Imagine I get a request from a user to fetch the list of data. It goes to the server and then checks the cache. If I have the cache data available, I'll serve it from here. If I don't, I will go to database layer, save it here, and then return it. And this goes back. So in this scenario, the only cost that we are incurring with respect to database costing is the first call whenever we don't have the data in our cache layer. The second strategy is write through. In this, all the data that we receive is written to cache layer and to database layer at the same time. When we want to read, we'll always get the data from cache and serve it back to the user. So in this scenario, we'll always have the data updated in our cache layer and it will always be available. Now the third strategy that I am covering is write back, or we can call it as write behind as well. Why we call this as write behind is when we perform the writes in our application, so they will go to the data cache layer first, and those updates will collectively go in batches to update the database for the persistent storage. Now, if you understand, if your cached layer in this scenario somehow fails, you don't get to update the database. You will miss that data in your persistent storage. Let's talk about another strategy, which is known as write around. Write around means we will be skipping the cache layer. So when we are doing the writes, so the writes directly go into my database. They will not go into my cache layer. This means when I'm going to read the data for the first time, I'll not have the data in cache. In this scenario, the cache will go to the database, update itself, and then serve the data. Now let's talk about another strategy that's called read through. Earlier we covered write through. This is read through. So in read through strategy, we'll have the cache layer sitting in between of the read queries between my database and the servers. So when I hit a read request, the server will take the request directly to the cache. If the data is there, it will serve back. If it is not there, it will communicate with the database, fetch the data, and then return. So now let's talk about cache invalidation, or how to clear the cache, because until now we have been writing the cache, but since our memory is limited and it's costly, we'll need to limit the memory storage that we have. So we have a couple of strategies there. One of them is the least recently used. So that means we'll evict the data that has been used from quite some time. So this would mean we can set up a TTL when we are storing the data. So if in case, let's say I am serving my profile data via cache, so I can set the TTL to, let's say, 5 minutes, just in case the user comes back and sees his profile again and again. So I can serve it from my cache layer. And then there is another strategy called as least frequently used. So in this scenario, we will remove the data that has been infrequently used. So we'll have the most frequently used data at the top of the layer so that it can get reduced. To implement cache, we can go by implementing some tools like Redis or Memcached. So Redis is an open source in-memory data store that has multiple data types and optional persistence to help you to store data. The multiple data types help you to store data in different format like lists or strings or hashes. In the case of Memcached, it is a simple high performance distributed memory caching system. It uses a straightforward key value store and focuses on simplicity and speed. Memcached is multi-threaded and scales by adding nodes